I work in the technical, I'm part of the technical services team. I work as a technical service specialist, and I've been in the field for about 35 years. All right, so we're going to do an introduction, which will show you what the equipment's capable of. We'll go overview and application. We're going to look at installation and settings. We'll take a brief look at how the system operates. And at the end, we'll look at some troubleshooting. So this is your Gen 3 EVOX AHU and outdoor unit. So Gen 3 is completely modular. When we designed this system, we designed it to be the most versatile system on the market. Here's what it can do. Well, it didn't play much. It's not wanting to play it.
Let me see it first. I got you.
There we go. Lock and lock. Screwless connections, completely modular. Completely modular, completely versatile. Up, down, left, right, low boy, left return, low boy, right return. 6 different installations. All right. So part of our development in Gen 3 was to try to reduce the chassis size, the size of the equipment outdoor, because we had some objections, especially on 36 and 48K. So we reduced the size on Gen 3 at the top and gone to single fan units. The only unit that will come as a double fan will be these 5-ton hyperheat unit. These are your cabinet sizes and dimensions. The 1.5 and 2 are in a 14-inch wide cabinet. The 2.5 and 3 are in a 17.5-inch cabinet, and the 4 and 5 are in a 21-inch cabinet. These are your product matchups. I want everybody to look at the 36K X6 high rated. Those are your performance numbers. Cooling is 36,000. 18 SEER with a 12.0 EER. Heating is 37,000. 12 on your EER. It actually has a 10.5 on the HSPF and 1.9 on your COP. That is rated at 5 degrees Fahrenheit. Line set sizes. Everything on this line is 3/4 and 3/8. All right. It's capable of doing multi-voltage without any switching. It is auto detect, so you can wire this for 115 volts or 208 230
On the indoor.
on the indoor. Now, one caveat, if you're going to use auxiliary heaters, you will have to have 230 volts for the auxiliary heaters. Dual communication. We use RS-485 for our communication scheme, or you can use 24 volts with a 24 volt thermostat. Better airflow. This is a constant volume, constant airflow system. It's got super easy maintenance. Unit's easy to take apart. Got a high efficient M coil. We went to the M coil so we could get the better airflow out of it. It's got smart humidity control built in for cooling. It also has a AHU IAQ kit, which is a filter box that is 1, 2, or 3. You can use a 1, 2, or 3 inch filter in. Back to the Vicom technology. You may have to hit play.
Yep. Gotcha.
All right, 485 communication. That's the method we prefer. Or you can use a 24 volt thermostat with S1, S2 communication between the indoor and the outdoor. All right. Reason we made this dual voltage is so we can take out a gas furnace and put this air handler in its place without having to make any major changes in the wiring. It's an easy conversion for different required voltage. Again, it's auto detecting. So if you wire it for 115 or 208 230, it will take off and run. There's nothing to change. You will have to use 208 230 if you're going to use electric heat strips. Back to the modular design: upflow, downflow, horizontal left, horizontal right, low boy left and low boy right. All right, so these are our numbers up to a 19 SEER, ER 12.5, 10.8 on your HSPF2, and 2.14 is your actual COP at 5 degrees. This system will actually produce 100% of its heat output down to -5. You have multiple control options. We can use our wired controller. That one on the top is our new smart controller, which is the one that Gensco will be getting. You can use the mobile phone app to control it remotely. It works with Google, Alexa, Apple HomeKit, and IFTTT. Every unit comes with a handheld remote control. You can actually control the unit with the remote control. We have a central, you can do central control on it. We actually have a central control designed for our systems. You can do remote on off. Think front desk control at a hotel. And you can use 24 volt thermostat. If you have it set wired for complete communication, you can do, we have over-the-air updates are available. The new smart control will have eye check diagnostics, which is also available in the app. 3-stage heater control for anything, any heater that is 15K or above. Open ADR smart grid, that is for your demand response from the utility companies. And the touchscreen smart thermostat. Which is right here. That's the demand response for you. That's open ADR for smart grid. Filter module. 1, 2 or 4-inch filters. The module has tracks that slide out to put a 4-inch filter in it. The tracks are aligned so that you can use either a 1 or a 2-inch out of the box. It also has a magnetic door. So there's no screws or anything to take out to get to the filter. Easy to install with the modular design. It's got screwless connections, everything, all the buckles. You can separate the modules from the buckles. It's a slim design so that it makes it easier to get in and out of attics. The modular design also plays into that. Because I don't know how many of you have had to shove one of those things, one of those full-size air handlers up through an attic hatch, but it's not easy. Ours, you can separate the modules and take the modules up one at a time, and then you just reassemble them in the attic. One man can carry one of the modules. And then we have, again, this is the low boy, we have flexible installations. It's very flexible. Here's our constant CFM. You look at the chart, look at the curves. Our airflow curves are dead flat. So they will deliver 100% of the airflow, the rated airflow, all the way out to 1 inch of water column. It will start to fall off. Somebody got a question?
Keep going.
Okay, take care of it. All right. So it will start to fall off at 1.2 or after you get past 1.0, it'll fall off a little bit. Once you get past 1.2 though, however, it will fall off the cliff. So pay attention to your ductwork. All right, so right here is your AHU power block. That powers the electric, that powers the AHU. This is installed right now with a single breaker electric heater. You can run 100, you are capable of running 115 to this. And or 208, 230 to this. It's got a window for the display so that you can see operation, check parameters, and see any fault codes without having to remove the doors. All of our units come with nitrogen protection. Before you install it, make sure you release the pressure using the black button on this green cap here. They are all, excuse me, they are all straight flare connections. Intelligent error code check. So the homeowner can actually see the error code before they call. They can tell you over the phone if there's an error code. If you're so inclined to tell them to go down and look at it. All right, here's the coil layout. We have T1, which is your return error sensor. If you're using the wire control, T1 reverts to the wire control. You have T2, T2A, and T2B. Those are all coil temperature sensors. The way the system controls capacity and algorithm and speed, T2, T2A, and T2B are all average to give you one T2 temperature that it uses. You have the EEV that is wrapped in a very sticky tape. That is put there for the noise and vibration. There's your nitrogen release on the front, and down at the bottom, mounted on the drain pan, is your A2L sensor. So this slide shows you the different layout of different size coils. So the T2, all the sensors are going to be in a very similar spot, but they will change. They will have minor changes from the 1824K to 3036K and the 40 and 48 and 60. They will be in slightly different spots. The refrigerant sensor will not change. It will be in the same spot every time. All right, so the ST1 and even the 120N, which is the white thermostat on the bottom, or white control on the bottom. They both came with they have a weekly timer. You have up to 8 program periods in a day, per day. As follow me function, they are remote control compatible, which means you can use the handheld remote to change the temperature on the thermostat. It's dual control capable. So you can put one system in the house, have a control upstairs and a control downstairs, do individual programming, and it will switch back and forth. Last call will be the one that gets the demand. It's capable of group control, which means you can control more than one unit with one control. And then it also has rotation and backup. So you can have 2 units. You can set by address, you can set one to run at this time and another one to run at this time. On the left, so you will have fan speed control. You will have low, medium, high, turbo, and auto. Two-wire controller, one system, 2 wired controllers for one system, first floor and second floor. That's what we just discussed with the dual control. Remote control, the wire controller. It will display. It can display it. They will display error codes on the screen if there's a current error code. Comfort and energy savings adjust. The wire controller Wi-Fi dongle it does not have the Wi-Fi dongle in it anymore because the wired controls have, the wired controls have Wi-Fi built into them. I'll take that out, Eric, but that was for our old 120X control that didn't have Wi-Fi.
Yeah, the ST1, it has the Wi-Fi.
It has the Wi-Fi, and even the 120N has the Wi-Fi, so that's why the dongle was no longer there.
It can be controlled remotely.
Yes,
Yep.
with the Midea, it's Net Home Plus app. Okay, so here's what I'm gonna tell you about Wi-Fi, okay? I found that most of these Wi-Fi thermostats have a lot of trouble with 5 gigahertz band. So most of them will, what I would do is I would use that same theory with ours and try to connect it to the 2.4 gigahertz band instead of the 5. Most of them we have, I know I've had trouble with 5 gigahertz bands.
Most routers today are running a dual band and.
Right, they're running a dual band, that's what I'm saying. So if you have this, if you have the set, some routers will also do what they call auto connector or what they call priority connect.
Mhm.
And sometimes if it connects to the 5 gigahertz band, you may have trouble with it. So just try to make sure it stays on 2.4. All right, let's look at some installation. This is what comes in the box. This cable here on the left, this cable right here on the left, we're not going to talk about because that is for full 24-volt communication. That's the only way that cable applies. We do not recommend you do our system, especially a Midea indoor and outdoor, and do a full 24-volt communication, because what you'll do is you'll take that machine from a 19 SEER down to a 14 SEER on-off machine. These two black sleeves are for the line set connections at the AHU. It comes with adapters. If you're so inclined to use the adapters, we would prefer that you not use the adapters because that requires brazing. If you're going to use the adapters and braze, we want to make sure that you understand that you have to flush nitrogen through the system while you're brazing. If you don't, you will end up clogging up the strainers. And of course, your installation manual and owner's manual. All right, so here's a picture of the upper module. Notice in the red circle, those are the connectors for your blower motor, your sensors, and the EEV motor. Actually, and your A2L sensor is connected there. In order to separate the modules or even pull the blower, you don't have to unwire anything from the board. You take those plugs apart, separate them, and then you plug them back in when you're done. So there's no remembering how things wired on the board or where the plugs went. All right, so here's the downflow. Let's talk about downflow application. When you flip this thing in downflow, you're going to pull apart your plugs for the wiring. You only have to pull apart the plugs for the sensors, the EEV, and the A2L sensor. You do not have to pull the motor plug. So you're going to unplug your sensors, release your wiring on the wire ties. Those are releasable and reusable. Drop your wiring on top of the coil, unbuckle it, take the blower module off the top, flip it over on its head, and then you pick up the coil and set it right back on top of the module of the blower. You'll reroute the cables right here. There is a channel built into that pan that's covered by covered by a foam gasket. You can cut the foam gasket, fold it back, break the tabs out of the channel, route your wiring through it, and then fold the foam back over top of it. Run your cables back, make sure you get your cables back behind these two rails here. And then you just reconnect everything here and rebundle everything. The one thing you have to do if you convert this to downflow or horizontal left is the T1 sensor has to be moved. T1 sensor is currently right here. It is right here. There's the T1 sensor in its original form, in its original location. It has to be rerouted and put there in that rubber grommet if you do horizontal left or downflow.
It's also the same with the low boy application, right?
So, yes, the low boy application also requires movement of that sensor, because remember, your airflow is now going to be coming in through the top instead of the bottom. So low boy application also requires that. Okay, so now we don't have to take a chainsaw and cut one in half to make a low boy. So this is a correct low boy application and installation. This, however, is not. That is our Gen 2 air handler that a contractor in Canada literally took a sawzall, sawed it in half, and put it in as a low boy. And then wondered why it didn't work. And had the nerve to tell us, it doesn't say you can't do that in the manual. And this one,
Always a great thing.
that one is definitely not a low boy.
Oh.
Please don't do that to our area. There's no need for it. All right, so these are your transfer box or base can connections or dimensions. Gensco actually will make these boxes. So you can buy the boxes from them. They will be pre-made. They will fit these exact dimensions. This will ease your installation. There is a low boy kit that is available for this. If you're going to use this as a low boy, I would highly suggest you use the low boy kit. It makes the installation go much smoother. In order to separate these modules and install them as a low boy, if you don't use the low boy kit, you literally have to pull the coil and the blower out to be able to screw these to your transfer box. If you use the low boy kit, you secure the low boy kit to the transfer box and you just buckle the modules in place.
We do have the kits on order, but they're not here yet.
Right.
They were just barely getting finished in development process.
Right. Yes.
So we will have them
Yeah.
as soon as we can get them.
Yeah. So yes, they will have them. So that's what it looks like on the transfer box. The modules are separated to where they will only fit the one module. So you have a blower module and a coil module. So you can't crisscross them. That's what it looks like inside.
Hey, Eric, before you go on, are you gonna talk about the cables between them?
Okay, yeah, we can do that. Okay, so on the low boy application, we have actually pre-drilled we have knockouts on the modules for the low boy application. You have a knockout here and a knockout here. Depending on which side you use, depending on which way you orient it, there's also a knockout right here to bring your cables from here into the side and then reconnect down here in the front. And you'll use one of these knockouts up here. If you do it with the coil module on this side.
And there's enough cable wound up.
There's about 5 to 6 feet of cable in that thing.
So we got plenty of cable to, be able to do this, is what you're
Yes,
saying.
there's plenty of cable.
We don't have to cut and splice.
Do not cut and splice.
We just unplug, shove it through.
Unplug, shove them through, put whatever connector you're gonna put in the knockout. Pull them through, plug them back in. That's pretty much it. Let's see, so there's 3 integrated PC boards in this thing. You have a display board or it's basically, they call it a data conversion board. That's your 24-volt board. You have a main board, and then there's also a fan driver. The fan driver board is the one that is here on the right. Notice the heat sink. The heat sink is actually setting directly in the airflow. This box right here, this control box, comes out with the removal of 3 screws. You remove 3 screws, and that whole control box assembly will slide out of the air handler. The only caveat is that your main power, if you need to pull the board out and pull it out very far, you will have to unplug the incoming, the L1, L2 plug right here. It's on the back of the fan driver board. But it's real easy to get to. It's on the top. Once you pull it out, once you pull the module out or the assembly out, you just unplug it, and then the whole assembly fault comes out of it. All right, so slide out fan assembly. Again, what we were talking about, this is easy maintenance, part of the easy maintenance. You'll unplug your fan right here. You can unplug your fan right here. Take your 3 screws out, slide the module out, unplug the power, the incoming power to it. You can literally fold that assembly down. It will fold over and down. You can just leave it there. Take out these 2 screws, and that blower assembly slides out. Very simple. All right, wire connections in the AHU. All right, so S1 and S2, let's L1 and L2 are self-explanatory. That's your power coming in. S1 and S2, which are on the display board, is the wiring that goes from your outdoor unit, or goes to the outdoor unit from the AHU. CN7, which is right next to it, is your wiring for the for the non-polarity wire controller. Wire controller only takes 2 wires. It's HA and HB. S1 and S2 are polarity sensitive. So when you wire this, S1 has to go to S1 and S2 has to go to S2. If you crisscross them, it won't blow anything up. It just may not communicate. CM13 is Wi-Fi port. It says connect for smart port. I think that is, I might have to change that, but I believe that is going to be our wireless communication port. Right now, there's nothing on it. The pads are there on the board, but there's no connector there.
All right, that's, next year?
That's probably next year, yeah, because we're working on it. That's our wireless connection. It's going to be a sub 1, it's going to be through sub 1G. CN 14 is an interconnecting cable between the display and the main board. XYE is your central control or backnet controller. Wiring. We offer a backnet controller. We don't personally offer it. We have a backnet controller that's made by Intesis for us, specifically for this machine. So it is available. CN2 is remote. CN2 is your remote control. That's your remote on off for your front desk control. RNC are your 24-volt power for your 24-volt connections. The 24-volt connections are right here on the board. L is an outdoor unit malfunction indicator. That would wire from the outdoor unit to all the way back to the thermostat to set off, to turn on the light, malfunction light on the thermostat. Probably not going to use it if you're not using 24-volt to the outdoor, because that's an output from the board on the outdoor unit. G is fan control. Y1 is low demand. Y2 is high demand. B is your reversing valve. We do reversing heating. W is a heat pump heating call. So that is actually an input to the outdoor unit. W1 and W2 are your stages of electric heat. EAUX is your auxiliary heat or emergency heating. And then a DHBK terminal is for dehumidification. Now, the dehumidification terminal is not active for wire control, because we are using the wire, we are going to be using the wire control to control humidity. All right, here's the wiring diagram out of the box, or in the manual. You have, here's your 24-volt thermostat right here. Right here, here's your 24-volt thermostat connections. Let's see. CN7 right here. That's your HAHB. CN21 here is your S1, S2 to your outdoor. You have your interconnecting cables. All of your sensors actually report back to the main board. The main board then communicates those to the display board. So all the sensors report back to the main board. The main board sends out the signal here on CN34 for your blower control. Let's see, what else is there I need to talk about? You have work terminal and alarm terminals up here. CN23 and CN33. Those are dry contact. Those are dry contact relays, which means if you're going to use those, you have to supply an external source of power. The terminals, the outer two terminals on those are the only two that are active. The middle terminal does nothing. So make sure when you wire those, you use the outer two terminals. The work terminal is energized or closed anytime the blower is operating. The alarm terminal, you can use the alarm terminal for turn on a light, open the garage door, whatever you want to use it for. It will be active anytime there's a fault. In other words, contacts close anytime there's a fault in the system. We'll go through the board layout here. So your dip switches are down here in the position that it is in the air handler. The dip switches are on the left side of the display board. These are all setup dip switches, which we'll talk about later. Right here is the forced operation button. Forced operation button, if you press it first time, it puts the unit in forced auto mode. It uses a 24 C set point and runs auto mode off of that 24 set point.
What's 24 in Fahrenheit?
75.
Thank you. Couldn't remember.
Well, remember, I've done this once or twice.
Yeah.
All right. So, all right, push it again, and it puts it in forced cooling with a 24 C set point or 75 F. If you press it a third time and hold it, it will enter forced defrost. That may end up going away because we are putting a forced defrost button on the outdoor unit. And that forced defrost button on the outdoor unit will force a defrost no matter what the conditions are. All right, CN14, let's go around. Wire set. So this is indoor wire set. These two connectors here are the interconnecting cables that go between the display board and the main board. CN14 is your heater control. That's where if you're using an auxiliary heater, you're going to plug in your auxiliary heater. It actually doesn't look like this anymore. Now it's changed to it's a red 5-pin connector. That's for the three-stage heat. CN15 we're not going to talk about because that's for 24 volt. That's for full 24 volt control. That's the only time that's active. That's the only time that's needed. 13 is your COM bus for your XYE. There's your, at the top here, we've got your S1, S2 terminals and your HA-HB terminals. HA-HB is for the wire control. S1, S2 is between the indoor and the outdoor. Next to that, you've got your alarm terminal and your work terminal. Remember, the two outside pins are the only ones that are active. We have a UV LED connection. We are actually developing our own UV LED. It's not out yet. We actually started it about 1.5 years ago. April Air had a patent on it, and they stopped us. The patent has since expired, so we are back on track for our own UV LED. You can try to connect low voltage UV LEDs to these. Just remember that is a 12 VA max connection. So it's not much.
It's enough to run a relay.
It's enough to run a relay. Ours, when we do ours, is supposed to be a direct connection. So there's your L terminal, which is your light for the 24 volt thermostat. CRDS, which not really sure what DS is. I haven't seen that in the explanation yet. DH, EAUX, W2, W1, WBO, GY1, Y2. Those are your 24 volt connections. All right, main board. There's your interconnecting cables, CN14 and CN16. Across the top is where, well, through the middle, the white is the white terminal. Mark CN7 is your T2A, T2B. Number 47 is T2, that's the yellow one. black terminal, right about the middle of the board, is your refrigerant detection sensor. That is a communicating sensor, guys, so don't think you can bypass it, because you can't.
In the parts breakdown, that's called a gas sensor.
Yes, and parts breakdown, it's called a gas sensor.
And we did bring that in.
Yeah.
So
Yeah, I would have probably brought some in too.
we,
Yeah. Next to it, or right over top of it, is the EEV. It's the EEV or EXV connection. That is a 6-wire EEV. It is 12 volt. It is 12 volt. It is a 12 volt stepper motor. All right, CN12 is power to the transformer. 18 is a ground. 15 is, it says power for the fan motor, but actually, that is actually the control voltage for the fan motor. That is sent to the fan driver board. And then the fan driver powers both. ENC1 is a capacity selection. This should come out of the box. You should not have to mess with it. Matter of fact, when it comes out of the box, you're probably going to notice it's got about a half stick of hot glue on it. That's so you don't mess with it. CN46 is your T1 sensor. SW8 here, which is these 4 dip switches, and S1, our address is an addressing switch. So if you were to have multiples of these in a building, say on central control, you use these terms, you use that for addressing. I believe it goes up to 63, yeah, I think 63. Now, CN23, which is the most important part of this board. CN23 right here is your drain safety switch. If you put a drain safety in it, remember, outer 2 terminals are the only 2 that are active. The middle terminal does nothing. That plug is removable. It's on the main board. You can actually pull that plug off of it, wire it, and then stick it back. If you're going to put an external drain safety on it, right here, right next to it is this little black pin jumper. Right there. If you're going to put a drain safety on it, you must remove that pin jumper. Otherwise, the safety switch will never shut it off.
And it's just a little black double tap jumper, right?
Double, yep.
So you recommend pulling that off and dangling it and let it just sit on one of them? And
You can, yes, and that's what I would recommend. Just in case you ever need it. Although realistically, you could take a wire, although realistically, you could put a jumper wire on the other connector. Indoor fan motor board. This is your fan drive. That is a true DC motor. So it will ohm out like a 3-phase motor. CN1 is your power input. That comes from your L1, L2 from your power. That's where your power plugs into the board. CN12 is power out to the transformer. CN11 is CN11 just goes to the main board. CN50, which is this 3-pin socket right here. It's just 3-pin socket right here. That is your DC volt. That's your power for your motor. That's power for your fan motor. CN13 next to it is your control voltage for the fan motor, which is set from the main board. Heater control. All right, so you have an option of 3, 5, 8, 3 kilowatts all the way out to 25 kilowatts. Your staging control runs across the top. 8 kilowatt and 10 kilowatt are two-stage. And then again, anything 15 kilowatt and above becomes three-stage heat for the auxiliary heat. Now that's, some of that's controlled internally. It is a two-piece heater. This table is your MCA and MOCP for your electric heaters. This is in the installation manual or the knee pad that comes with the unit. Wire connections, proper practices. So on the low voltage or the communication, we are okay if you take that twisted string, that stranded wire, twist it together and stick it, not twist the wires together, but twist the cable, twist the strands and stick it under that T screw and tighten it down. Just don't over torque it. We're not, however, okay with L1 and L2 being done that way. Everybody understand that right there is going to cause a problem down the road. All right, so on your communication cable, I don't like to see crimp-on terminals on the communication cable because they create a choke point for the communication. Also on communication, while we're on communication, no wire splices in my communication cable. If you're going to do wires, if you're going to have to splice the wire on the communication cable, I will only accept a soldered connection. This is what we prefer to see on the high voltage end, on the high voltage side of it. Those are just crimp-on standard crimp-on terminals. They're a pain to do, but yes, that's what we like to see. We have tried to get set screw type screw loads put in these machines, and for some reason, China cannot seem to find a vendor for those, even though they're pretty well readily available here in the United States. For some reason, they just can't find a vendor for them, so they've stuck with these T cables. We're stuck with these T screws. If you're going to use the T screws, like I said, now that T screw is actually good for anything 10 and below. You can actually you can just take the wire and put it under the terminal. If you get anything above that, you really need to have crimp-on terminals. If you don't, you're going to cause yourself some problems. Yeah.
Since we are running communication wiring, and in most cases in a retrofit application, we'll have existing 18 gauge wire.
Yes.
From indoor to outdoor, and we show 16 gauge stranded shielded wiring. Are we okay with running standard?
Yes.
18 gauge
Yes, you are okay. That's what we recommend 18 gauge stranded shielded cable for our communication cable. However, if you're in a spot or on an installation on a retrofit where you cannot run a new stranded or a new shielded cable for it, you can use the existing thermostat wire. Just be aware that you could experience some interference issues. If you experience so when you do those connections, what I want to see is, because we don't like multi-conductor on shielded stranded. So if you're going to use the existing thermostat wire, pick the two wires that you're going to use, snip the rest of them off back at the outer jacket. If you have communication issues, there's one thing you can try, and that's to take your extra conductors, twist them together, ground them at one end, like you do the shielded cable, and sometimes that will help with the interference.
But it will work with. It will work standard. So
it will work, yes.
We're gonna have a lot of dealers doing.
We have a lot of these out here. A lot of our Gen 2 equipment out there that is on standard thermostat wire. It works fine. Just like I said, just be aware that you could experience, depending on how the wires run, you could experience some interference issues. All right, outdoor board wiring. L1 and L2 are on the left. Notice the two X's here. This is where S1 and S2 used to be. We had too many guys that were wiring R and C from the 24 volts to those terminals. They were immediately blowing the comm chip in the board. So those terminals have actually been moved. The two X's do nothing, and your S1 and S2 terminals are right here now. They've moved them away to try to keep people from screwing it up. Also, well, we'll get to that.
Far away from that one.
We'll get to that. All right, L1, L2 is your power. Your low voltage is pretty well, let's talk about these two. The rest of the low voltage is self-explanatory. It's the same as it was on the indoor. D and W are going to confuse people. Now, this is only applicable if they use 24 volt thermostat or 24 volt full control. W is actually an input from the indoor unit, from the 24 volt thermostat, that puts the heat pump in heating mode. So if you were to wire this, let's say you had somebody out on a Friday night and the wire control has failed for whatever reason, and the only thing they have is a one heat, one cool conventional thermostat, and they need to get heat or air on at Bob and Mary's house. They can take that one heat, one cool conventional thermostat, wire it up, and it will make it work for heating and cooling. So the W from the heat from that conventional thermostat will go out to the outdoor unit, and it will send the heat pump into heating. A Y1 call or Y2 will tell the heat pump that it's a cooling call. So you can do that as an emergency purpose. D is the defrost output. So if you're using full 24 volt control, D is replaces your W back in that's for your auxiliary heat for defrosting. So you send that back in, you put it on W1 or W2, and that's your defrost heat. If you're using auxiliary heat for defrosting. You don't have to do that with ours, because when ours goes into defrost, the indoor blower shuts off. So it doesn't blow cool air in the house while it's in defrost. Okay, so dip switches are right here. They are right here. Yeah, right here. This red block right here. If you're using S1, S2 to the S1, S2 communication between the indoor and outdoor, you do not have to touch these dip switches. If you have to use 24 volts, even if it's an emergency, SW1-2 has to be turned off. That puts the outdoor unit in 24 volt mode. So for emergencies, if you have to wire for 24 volts, you have to turn that switch off. You do not, however, have to turn any dip switches on the indoor unit. That will auto detect.
Now, Eric, since we're gonna be having an air handler, or if it's for an indoor port, there's really no circumstance we should be required to run 24 volt control to our outdoor unit. It should always be able to be two-wire communication. Right.
Even if you're going to use a 24 volt thermostat, we always want S1, S2 communication in the indoor and the out.
Yes, which is what we always want to recommend. We want
Yes.
to avoid 24-volt wiring to our outdoor unit in every
Period.
situation possible.
Like I said, if you do full 24-volt communication, you've just taken our machine from a 19-SEER down to a 14-SEER on-off machine. So we always want S1, S2 communication. So, yeah, the reason I'm discussing this is because somewhere along the line, somebody's gonna have an emergency on a Friday night and need to get somebody's heater air conditioning going. It's that simple. Other than that, I don't recommend it at all. Okay. So this is the flare and brace parts. This red box you all can ignore because Gensco is taking only the hyper heat or the high heat versions. That is for the standard heat version of the 18K. The hyper heat version of the 18K will have 3/4, 3/8 line set connections. Okay, so let's talk about this. So here we go again. S1, S2, they moved them off of that board to keep guys from screwing it up. They also built in voltage protection on it now. So the terminals are those S1, S2 terminals are actually protected now out to 50 volts. So if somebody does happen to wire 24 volts to those two terminals, it's not supposed to blow the board.
Eric, do we have units that could have the old wiring then, not it in the new location?
No, you
Those
will
are
not.
important.
Okay.
No, you will not, because your units, so that board design came out when we started developing Gen 3. That board design's been out for at least a year.